All right. Amy Barraclough.
Yes,
Is that pronounced correctly?
pretty much.
And you're the planetarium director at Rowan University.
Yes.
So what is that?
The planetarium? So the planetarium, it's you can kind of imagine it as a big room with a domed ceiling, and we project the nighttime sky onto it.
Cool. Is that like for a class, or is that just something like the public can go see, or is it just for students? Or
No, it's both. On the weekends, we're open to the public, so anybody can come into one of our scheduled shows and learn about astronomy, learn about the nighttime sky. We also do laser concerts, which are really fun. Right now, on Friday evenings at 7 and 8:30 p.m., we do Laser the Weekend, and what's our other show? Give me a second. Laser Taylor Swift. I don't know why it took me so long, that one. We've been doing Taylor Swift for about 2 years now. So I don't know why it took me so long to to remember that that's the one that we're doing. But yeah, it's been a really popular show.
Cool. So how did you get into planetarium stuff and like the night sky and astronomy?
So I've always had
Is it astronomy or astrology?
It's astronomy. Yeah.
Okay.
Yeah. But I've always had a fascination with it. I never knew that I was going to do this as a job, though. When I went to my undergraduate at UW Stevens Point, I had actually enrolled as a music student. I was going to go into music teaching. I wanted to be a choir teacher. And my freshman year, I didn't get into the program, which wasn't really surprising. Nobody really does their freshman year. So I was considered an undeclared major, and I had a lot of free time to take whatever classes I wanted. And since I had a lot of interest in astronomy and saw that they had an introductory astronomy course, I thought, okay, why not? Let's take this. That sounds like fun. So our university, like Rowan, had a planetarium, and our professor was the director of the planetarium, and he would take us into the planetarium every week for our lab work. And one day, I'm in lab, we're in the planetarium, and it is a day that I am incredibly tired. The labs were always at like 3 p.m, so it was kind of like right as you're starting
crashing.
Yeah. And so I remember this particular day, like I'm really, really tired, but I don't want to fall asleep in class because that's kind of rude. So I decided to sit right next to the professor. That planetarium had the seats were in a circle; they were concentric. So the console was just on one part of the room, and then the seats were in a ring around it. So I sat right next to where he was standing presenting, hoping that would keep me awake. And I find myself like midway through the class, just my eyes are drooping. I'm starting to fall asleep. And everybody else in the class already is long since asleep. It happens all the time. He expects it because it's a dark, relaxing room. But as I feel myself like just kind of sinking into my seat and starting to fall asleep, my professor leans over and says, "Amy, I need to talk to you after class." And boy, if that didn't wake me right up. So after class, now I'm completely panicked. Like, what did I do? Why am I in trouble for falling asleep? Everybody else already did it. So he talks to me after class, and he says, that he has an opening for a student presenter in the planetarium, and would I like it? He thinks that I would be really qualified. And I thought, sure, that sounds like kind of a fun way to kill some time and earn a little bit of extra money as I go through school. So, I become a student presenter, and he starts taking me to conferences where I get to meet lots of other people that all are just as enthusiastic about the night sky as I am. And I start to see myself in this role. And so next thing I know, I've switched majors from music to physics. We didn't have an astronomy program, so I had to do physics. And found myself working in planetariums full time.
And you mentioned your quantum mechanics class earlier before we started filming.
Yeah.
What a great time to bring it up.
Yeah. So quantum mechanics, that one was a very very tough class. I have since learned that the microscopic universe is not one that I can just wrap my head around. I'm more for the macroscopic planets and galaxies and stars. But that class was kind of a good learning
Can you
experience, I
explain
think,
that?
for our professor.
What is a microscope? Is it just the view that you're taking
No,
of?
so quantum mechanics, they're trying to explain and define the properties of microscopic things like atoms and electrons,
Oh,
and yeah, so we're talking like the
so you're
smallest parts of
zoomed in.
yeah,
Yeah.
you're
Okay.
talking about the very smallest parts of the universe where my brain is kind of attuned to the largest things in the
Mhm.
universe. So I go into this quantum mechanics course. It's an upper level physics course for us, but we're all undergraduates. And our professor, he was fresh out of his PhD program. He was a brand new professor, never taught before. And he was thrown into this upper level course. And first day of class, he puts an equation on the board. I think it's a universal equation for quantum mechanics, but it's been 20 years. I don't remember very much. And admittedly, learned almost nothing in his class. But he goes to the board and, he starts writing out this equation and says, well, you guys already know all of this, and starts like
Ew.
halfway through the
Whoops.
semester already, like day one. And he is just flying through it. And of course, everybody in the class is trying to tell him, like, no, we've never learned this before. We don't know it. And he insists, no, you're all just being modest. Like, I know you guys know this, and, you'll be fine. So he just keeps on going. So a couple weeks later, we're partway through the semester and we get our first exam, and everybody fails. Unsurprisingly, because, he jumped.
Did he curve it at least?
Well, yeah, so that was the wake up call for him that, oh, maybe this class of, undergraduate physics majors, they haven't seen this before. They don't know this, as they've been trying to tell me for the past 6 weeks. So he changed his whole teaching style, and I think managed to bring a lot of people along with him. But by that point, like, I felt so in over my head. I don't think that I ever quite figured out what he was getting at.
Sounds like a good professor to change his whole
Absolutely.
everything.
Yeah.
You know.
Yeah, I think he really is a good professor, despite having, not learned anything in his
Yeah.
class.
Yeah, that's cool. You were also saying you were on. So you were on CBS Nightly News, the 6 o'clock news story.
Yeah.
What? You were featured over before the Gaza war.
I think it was the Gaza War, yes.
What was it? What happened?
So, I guess it was a little over a year ago now, back in May, where there was a huge solar storm that had caused bright auroras that were visible all the way down in Florida, I think also in Hawaii, and regions much, much farther south where you don't normally see it. And a reporter from CBS News had sent a blind email out to the planetarium saying, they wanted to talk to us about this solar flare that had happened. And so, I responded back and said, I'd be happy to talk to you about this. And so they came with an entire television crew. I think it was maybe 6 or 8 people showed up, and they spent about 4 hours filming their B-roll, filming their interview. We ended up doing the interview in about 5 or 6 different locations across the science
The
hall where
same
the
interview?
planetarium, yeah.
How
And
did we? So did you like recreate the enthusiasm from the first one?
well,
We were trying to anyway.
yeah, so I mean, we just had to keep it all going, and so he would, ask a question he had already asked, or ask more questions, just so that there was different scenery as we were going through this whole interview. And then they cut it. It was probably an hour's worth of or more worth of interview content that they had taken, and they cut it down to a 2-minute segment. And I knew that it was going to be playing that evening on CBS News, but didn't really know where within within the lineup of whatever other news stories that they have, that it was going to be there. And so we decide as a family, like, we just really want to watch this episode of CBS Nightly News. It's not something we're normally watching, but turned it on, and they do their opening title credits and everything, and then there's me on national news, very first story, and then they start getting into like the continuing war in Gaza and whatever other stories were going on.
What a cool experience.
Yeah,
that's awesome.
It was bizarre. It was seen by millions of people, which was a whole new experience for me too. Normally the planetarium, it's a really dark space, so people don't see me when I'm presenting. So I'm not used to being in the spotlight. So
and here you are.
Yeah,
now.
like here I am now.
Wow.
Here I was a year ago on Nightly News as the lead-off story, and I think I prefer being in the dark.
Very cool. Very cool. So the reason I brought you on is I've been like really, I don't know, I've been like fixated on this planet that they found 124 light years away, K212b.
Mm-hmm.
Are you familiar?
I wasn't familiar with that one in particular, so I did look it up. There are thousands of exoplanets out there, so knowing them all by name, it isn't something that's really in the realm of possibility. But I did look it up. It's kind of a fascinating planet. What in particular drew you to it?
Well, so what drew me to it was that I think they said they're 99.4% sure that there's life on this planet. And the reason that they're saying that they're sure of it is because there is an element that they're able to pick up from the James Webb Telescope that is also present on Earth.
Mm-hmm.
And this element is created, or I don't know if it's an element or chemical, whatever it is, it's created by microorganisms on Earth.
Okay.
So they're assuming that since they're seeing it on this planet, that it's also created by microorganisms. And the planet has, I don't know, a much higher percentage of this element on it. And on Earth, this element is created by microorganisms in the ocean. So they think that this is a very large ocean planet.
Okay. So I don't know what the likelihood of life being on this particular planet. In fact, I actually would be shocked if life did exist. The planet
Anywhere?
on that whole planet, nowhere. It orbits 5 times closer to the star than Mercury orbits the sun. It's about 7 million miles away from its host star. So it's orbiting.
Oh, so it's hot.
It's very hot. It's orbiting in about 8 days. And
wow.
It's very, very fast orbit.
Well, 8 days, so it must be a smaller star then.
It's about the same size as the sun. It's classified as a G-type star, so it would be very similar in size and temperature to our sun. But that also means that
it's flying.
Yeah, it is. And the sun, our solar corona, the sun's atmosphere, outer atmosphere, extends about 5 million miles out away from the surface of the star, of our sun. So this planet orbiting 7 million miles away from its star, it's just outside of the star's atmosphere. It's practically orbiting in its atmosphere. And it would be probably about 1 million degrees there, because the outer atmosphere of the sun, although the sun's surface is only 10,000 degrees, the corona, its outer atmosphere, is about 1 million degrees. And we don't really know why.
Wow. So if a planet, just to put it into perspective, if a planet in our solar system were as far away from this sun as K212b, how fast, if it were the same rate as is in our solar system, how long would it take a planet in our solar system?
Well, so we can
that distance.
So we can imagine that it would be pretty comparable. Since
8 days.
Yeah,
that's how close it is.
It's very, very close. The stars, the star that K212b is orbiting is so similar in size and temperature to the sun. That with how close it's orbiting.
Wow.
Yeah, it would
Well,
be
this is
orbiting. It would be orbiting our sun in 8
this
days.
has changed everything. Okay.
So I mean, Mercury, which is 5 times farther out than K212b, that's a planet that's still its temperature
Mhm.
on the daytime side is at 500 degrees, and its nighttime side is almost minus 500 degrees. Because there's no atmosphere to trap that warmth, and so the day side gets all of that sunlight, gets all of that heat, and then the night side it just disappears out into space.
Do you think there's life on any other planet out there?
I think that it's possible. I don't know that it's likely on any of the exoplanets that we found so far in our solar system, or in our not in our solar system, in our galaxy. Um, but I think it is possible. The only reason why I don't think that it's likely with the exoplanets we've so far discovered is that it's really hard to find an exoplanet. Stars are incredibly bright, right? We know this, but the planets themselves, they're not creating their own light; they're only reflecting sunlight. So to see them, you have to somehow find a way to block out the star's light to be able to image it.
Hmm.
So the planets that we're finding, we're either finding because they're so far away from their star that when we block out their light, then we can see that reflected sunlight somewhere, out past the orbit of Neptune, basically. Or they're huge planets, very, very close to their star. And so we can see the gravitational effects as the two are orbiting around each other because the planet kind of pulls on it.
They
So
did say it was a larger. I think it
it,
was 3 times the size of Earth.
it's about 5 times, yeah.
5.
So about the size of Neptune.
Okay.
Hmm.
Oh, wow. Could we talk about the James Webb Telescope a little bit?
Sure.
And how it's even able to see 124 light years away?
That's nothing. It can see almost. I think the farthest thing that it's discovered so far was about 12 billion light years
What?
away.
I mean, when I think about this thing, it's just like a telescope, like a
Yeah,
huge Looney Tunes telescope.
kind of.
Is that what it is?
Well, so what it is huge. It's about the size of a tennis court. And it has these 18 mirror segments that are kind of hexagonal shaped, and they all kind of stack into each other to create that one big mirror, or that the telescope uses to observe. But it's not observing visible light like our eyes can see. It's actually it's observing heat. So it's looking for infrared light. So it's seeing the heat signatures of different objects. And so that's one of the ways that we can also detect, planets around other
Did
stars.
you say 80 billion light years?
12,
12 billion light
12
years?
billion, almost to the beginning of the universe. Yeah.
Wow.
Yeah.
That's
Discovered
the beginning of the universe?
just
What's
about.
outside of that?
We don't know. We have no idea. We think that the universe formed about 13.5 billion years ago. So beyond that, like we just can't see because light, it takes time to travel, but the universe has been expanding. So as it's traveling, the universe is getting bigger,
Mhm.
and that light source is getting farther away. So it takes longer for the light to get to us. So we'll probably never know like what's at the very edge of the universe because it's receding faster than we can observe it.
So if you are pointing this James Webb Telescope somewhere, like say it to K212b,
Hmm.
how long does it take you to like see the image that you're looking? I mean, does it take a while?
Yeah, I think that it would. I don't have an actual time frame to give you, but I do know from having visited the mission control where they actually downlink all of the data from the James Webb Space Telescope. Um, they aren't continuously getting all of that data. What they'll do is they'll use our network of radio transmitters to send instructions up to James Webb, and it will, give it a list of, I want you to observe this, and then this, and then this, and
Where's it
like,
located?
where's what located?
James Webb.
James Webb, it's out in space at a point called L2, Lagrange point 2, which is a stable orbit around the Earth, far away from it, about 1,000,000 miles, I believe, away from the Earth.
And
It's
it's
very
still
far
orbiting
away.
Earth?
It is, but it's orbiting very, very far away.
I didn't know things could be in our orbit that were that far away.
Yep.
That brings me to, I want to kind of get back to this, but since you talked about that, can we talk about the asteroids that are orbiting Venus?
Sure.
Do you know anything about the asteroids orbiting Venus? From what I've heard, there are 3 asteroids orbiting Venus. It's a family that were hiding in the shadows of Earth. We couldn't see them. They caught a glimpse, and they are so close to the orbit of Earth. They are closer to Earth than our moon at some points in their orbit.
So there are a lot of these asteroids orbiting, part in the inner part of the solar system, kind of near Venus. There are thousands of them actually. And recently, about 2 months ago, I think a study had come out where they had observed 20 of these known ones, and 3 of them were found to have the potential to come close enough to Earth that they could impact it. And because they're larger, they're kind of deemed the city killer asteroids. These are asteroids that if they impacted Earth, they would wipe out a city if they had a direct hit on that city. But most of the news articles that you would read about it are completely overblown. Yes, those asteroids would destroy a city if they were to hit. But the timescales that you would have to have for those asteroids to change their orbit from being in this semi-stable orbit around Venus to suddenly being flung out towards the Earth, the research study that they had based this off of looked at the solar system over a period of about 36,000 years. So 36,000 years from now, maybe we'll get hit by one of these 3 asteroids that were observed, but they were already known. It wasn't a new discovery of these asteroids.
Media loves playing tricks on people.
They really do, yeah.
It got my wife, she was reading and going crazy. She's like, they're hiding in the shadows.
That is true, though.
One little thing could just send it.
There are, in fact, asteroids out there that we haven't yet discovered. And many of them would be these near-Earth asteroids that could pose a harm to us. And so we do have satellites and telescopes that are designed specifically to help us identify these different objects. And one of those is the Vera Rubin Observatory, which will be coming online within the next, I think, couple of weeks. Last month, they had released their first images from the Rubin telescope, but they're still trying to do their final calibrations on it before it starts its 10-year mission to observe for these transient objects, things like near-Earth asteroids or...
So we're going to hear about all kind of shit. That's we're going to be scared to death for the next 10 years is what you're saying?
Well, I hope not. No.
Wow, this one's it's right there.
I mean, most of the time when we find these near-Earth asteroids, there was actually just a news article, I think, that came out yesterday or a couple of days ago about a near-Earth asteroid that they discovered right after it passed by the Earth. It happens all the time. Yeah. But near Earth could be, 50 million miles away, or it could be 240 million, about the distance of the Earth to the moon.
That wouldn't even be visible.
No, none of them are. Yeah. And so we often don't see them until they've already passed by, like in the case of this one that they discovered a couple of days ago. It was discovered a day after its closest approach to the Earth. So, after they discovered it, they were able to calculate.
So what if that was coming
orbit
towards Earth? Would they be able to see it in time to warn anyone?
Probably not.
Oh, they would just hit?
It would just hit. I mean, it happens all the time.
Yeah.
But every meteor strike that we have, every time you see a meteor shower, that's space rocks that are hitting the Earth.
So someone's dying every time you see a shooting star is what you're saying? Okay.
No, not at all. Most of the time, the meteors, they're little pieces of rock or ice They're tiny pebbles or dust.
And they light up the sky like
yeah,
that?
they're vaporizing in the atmosphere because they're slamming down at such incredible speeds, like mind-blowing speeds, that they light up, they ionize and create that streak of light.
That's so cool.
But sometimes there's big enough chunks that they make it all the way down to the ground, and that's where we start getting those meteorites that you can see. But again, like usually they're really small pieces of rock. I think what year was it? 2013. There was a large meteor strike that hit Chelyabinsk, Russia, and when that one had impacted with the Earth, the the rock itself had kind of broken up in the middle of Earth's atmosphere above the city of Chelyabinsk. And so it wasn't so much the impact that was a problem because, it was disintegrated, but instead you had the shock wave from the asteroid breaking up, and it broke some windows all around the city.
It was just energy?
Yeah.
Wow.
Yeah. So you ended up with thousands of people having gotten injured, but mostly because they had all, they were seeing this bright meteor in the daytime sky, and they all went out to the window to look up and, what is that? Wow. And then the shockwave hit them and blasted the window broken apart. So, they would get lacerations on their face or hands or wherever. And sometimes it happens.
Wow.
But those large ones, like the ones around Venus that you were talking about, those ones are going to be large enough that we would detect them before they impacted. The question is whether or not we would be able to do anything about it. And so we actually, and by we, I mean NASA. I'm not part of NASA.
Okay. We at Rowan.
Yeah, we at Rowan have no role to play in this. I'm just using the royal we, I guess.
That's cool.
No, so NASA is it's working to try to find ways to try to deflect or protect us from these larger asteroids that could impact us. So they worked with the Advanced Physics Laboratory based out of Johns Hopkins University in Baltimore. And they built a sort of a test mission called DART. And DART, it stands for the Double Asteroid Redirection Test. It was a satellite that was sent to an asteroid that's near Earth, not in any danger of impacting us, but just one that we are aware of and that we can study easily and reach fairly easily by satellite. And so we had sent this spacecraft to the asteroid, which the asteroid itself has a little tiny asteroid moon orbiting around it. And the goal of the mission was for the spacecraft, the satellite, to crash into the little asteroid moon and see if they could push it off course by crashing into it and change its orbit a little bit. And so that happened about a year and a half, maybe 2 years ago. It crashed into the little asteroid moon, and it pushed it off of its orbit significantly. I think actually more than they had even originally calculated. So that was able to kind of prove that.
How does a moon, how does it have a little asteroid moon?
Well, because everything has gravity. Even tiny little asteroids, they all have asteroids.
What is the moon?
It's another asteroid. No, you have an asteroid about the size of a city, and then a little house-sized asteroid or something. I don't know the scales of it, but you can imagine,
and pushing the moon off of the orbit of the asteroid.
Mm-hmm. Yep.
Do you understand how that works at all? How throwing something out of the orbit of that asteroid would throw that asteroid
so again,
out of its own orbit?
So it wouldn't change the orbit of that asteroid. It changed the orbit of the asteroid moon.
Okay.
And that was the plan. We didn't need to change the orbit of the asteroid itself because again, it's not going to impact the Earth. It's not endangering us in any way. But it was one that we could easily get to and easily test. And so we tried to push that moon out of the way just to see what happens.
And that asteroid is just a large rock
Mhm.
that's orbiting Earth?
Yep, it's orbiting in the asteroid belt, between the orbits of Earth and Mars. It is kind of on the closer side, so it's considered a near Earth object. But it isn't really orbiting the Earth. It's
Just hanging out.
just hanging out.
And how did they end up? How would they end up like breaking the plane of Earth to the point where they would strike an asteroid? Like,
You'd have to find the asteroid early enough that you'd be able to,
well, I'm saying, how would an asteroid ever like start hurling itself towards a planet?
it has to be disrupted by something. So a lot of times, the disruptor is Jupiter. Jupiter is the largest planet in the solar system, so it has a pretty big force of gravity. And if the two objects get a little too close together, as they're both orbiting the
The
solar
things that are
system,
orbiting
yeah.
Jupiter.
Well, anything. If Jupiter, if as it's orbiting, it gets a little bit too close to Jupiter, as they're going through the solar system, Jupiter's gravity could slingshot it. Maybe it'll slingshot it out of the solar system, or it could slingshot it in towards the inner part of the solar
How
system.
doesn't that happen to like a planet?
It did at the beginning of the solar system. That did happen all the time. That's how our moon came into be.
Oh, and this is just where they all aligned.
Yeah, so all of the planets are now kind of in fairly stable orbits. So their gravitational pull on each other isn't enough to affect their orbits. They just kind of hang out right where they are. But billions of years ago, as the solar system was forming, there was what we call a planetesimal, which basically think of it as a baby planet, about the size of Mars. And it got flung into the inner part of the solar system, and it crashed into our hot baby Earth. And when it crashed, it vaporized everything on the Earth. So the entire planet just became magma.
Hmm.
And the planetesimal, which we call Theia, got absorbed down into the center of the Earth and became Earth's core. But a bunch of that magma, a bunch of that material kind of splooshed off. And that's a technical term. Very splooshed. Yeah, it's a scientific term. It kind of, splooshed off. I don't have a better way to describe it. Because, Earth was kind of liquid. And so a big chunk of it came off, and it became our moon. So when you study the composition, the mineral composition of the moon and the Earth, they're very similar. And that's because the moon, it splooshed. The moon was the Earth at one point, like it was part of it.
So is that how we have land? Is that sploosh? Like if the Earth was primarily liquid, that thing falls to the center.
So it was liquid rock. It wasn't liquid like water, but it was magma. It was lava. Earth was so hot from that impact that like all of the rock and metals on the planet, had heated up and become, like melted, molten rock, and that's what splooshed off and created the moon. We think that
it's crazy that it just like tossed it off.
Well, because it was still, it had rotational energy. So it was rotating around on its axis, and it continued to rotate as the object smashed into it. And you can see there's animations on YouTube and on NASA's website where you can see, the simulation of this happening. And it just continues to orbit, and like the two lobes just kind of break apart, and there's the baby moon coming off.
Luke, can we watch that by any chance? Real quick, is that possible?
Yeah, give me a second.
If not, no big deal. I really want to see this.
There, NASA's Ames Research Center, the new supercomputer simulation.
This one right here?
Yep.
Okay. Give me one. Hold on. I can lower this. I just can't see the TV. And we'll pick up recording right here.
So, splooshed.
Splooshed. That's amazing. That's really cool.
Yeah.
It's crazy how the Earth just absorbed, like it caught it,
Mm-hmm.
and it didn't just keep going.
Right. And I think a lot of that was because since it was still so early in the solar system's formation, yeah, everything was still really, really hot. And so, both of the bodies were just kind of molten. So they were basically liquid and, they just kind of grabbed onto each other. If they had been solid, there might have been a chance, that they could have just.
And how far was the Earth from the sun at that point? Do you know?
I think it was pretty much where it is today. I don't know that Earth's orbit has changed significantly. I know that Jupiter's orbit has changed dramatically, and because of that, it has kind of affected where all of the planets lie in the solar system. But I don't know that it changed Earth's orbit. I could be wrong, but I don't think it changed.
Have you heard that like haven't they found like some type of fossils on Mars or something like they really want to believe that there was life on Mars at one point.
Yeah, so Mars did have water. We have confirmation of that.
So there was life to some extent.
Not necessarily. We suspect that there would be because all life on Earth requires water. But we haven't had any like direct evidence that we can point to say this is, life that we found on Mars, but we are looking for it. NASA has the Perseverance rover on Mars right now. Perseverance landed about 3 years ago, back in February 2021. And Perseverance's job is to just drive around on the surface of Mars. It's driving around at a dried up river delta, so an area where a river met up with a much larger lake or ocean. And it's driving around there collecting these soil samples and rock samples to try to, hopefully collect some that have evidence of microbial life inside them. But the trick there is that Perseverance doesn't have a geology lab built on board like many of the other previous rovers did. The plan for Perseverance is that it's going to collect all of these samples, and then the Mars Sample Return mission will head to Mars, collect all of those samples, and then bring them back to the Earth so that we can study them here on the planet. Because there's a lot of scientists here. There's a lot of labs all over the world that would love to get their hands on some pieces of Mars and start studying them.
That's great. So in my head, it was like there's like this, because like the planets are slowly moving away from the sun. Is that true?
Very slowly.
Very slowly. So like we're in this like window of life on Earth. And at some point Mars was in the window, and then when Mars went, then it's like that's like in my head, that's the theory that I came up with. That doesn't seem to be even possible with this sploosh situation.
No. So it is possible that when Mars had water, which was about 3 billion years ago, that Mars had water, that maybe some kind of microbial life might have developed. We're not talking dinosaurs or plants and animals like we think of when we think of prehistoric life on Earth.
Plankton.
Right. We're talking like even before then, we're talking like the single-celled, amoebas or, the precursors to what we think of when we talk about life. Because 4 billion years ago or 3 billion years ago when Mars was wet, the life that we had on Earth was really just single-celled, organisms. And it wasn't until, billions of years later that then we start talking about things like dinosaurs and plants and, the mammals that eventually led to us humans.
So how close is like the closest solar system?
Probably, I would have to say it would be about 4 light years away. There is a star called Proxima Centauri. Proxima, means it's the closest. It's it's actually the closest star to the sun, and we have confirmed that there is at least one planet around it. So,
and like the James Webb Telescope has determined that there's no life on that planet.
Well,
or any other like it.
So Webb can't really tell us that. It does have the ability to study the atmospheres of exoplanets, and that can help give us some clues as to whether or not life might have developed. Because as you had said earlier with K212b, when it studies the composition of the atmospheres, there are sometimes signatures that they find that we know on Earth are caused by biological processes. Mm-hmm. But that doesn't mean that there isn't a chemical process that can create that same element. So all that James Webb might be able to tell us is, this chemical signature matches one that we know is created by life on Earth, but there are other explanations for how those could be. So I don't think that Webb is ever going to be, the proof, ever find the like direct
Mm-hmm.
evidence that life exists.
Are they working to make something more, like, even better than James Webb?
The next telescope that NASA is hoping to launch is the Nancy Grace Roman Observatory. And that one, I think, is, going to be better than Hubble and Webb. But some of that is just due to the fact that, it's going to be newer. If you think
Mhm.
about, like, your cell phone from 10 years ago compared to the cell phone you use today, it has a higher resolution camera, and can do more things than that phone could have done. Um, Hubble, although still an incredible telescope and still operating today, it's 35 years old. The cameras on it were built 35 years ago, probably more than that, because we had to design it, test it, build it, get it inside of a rocket, and then launch it into space.
Mhm.
Hubble being closer to the Earth, it's in a low Earth orbit. It's serviceable, or was when we had a space shuttle fleet. The shuttles were able to go out to Hubble, and they were able to install new science equipment and things onto it. But the shuttle fleet was retired in 2009, I think. So we haven't really been able to upgrade Hubble in quite a while.
Poor Hubble.
Poor Hubble, but it's still being used for some incredible research. It works really well alongside of the James Webb Telescope. Both of them are they have similar science missions that they're trying to study. And because one looks at the universe in visible light, so what we can see with our eyes, and the other is looking for those heat signatures. When we combine that data together, we can find even more detail than we could just from one of those telescopes alone. So when the Roman telescope launches, it's going to open an even wider view of the universe, probably one that we can't quite imagine yet today.
That's crazy. So this big theory that I kind of came up with, and it was like a combination of like these quantum mechanic things that like I've read or heard, and then like with this like multiverse theory with combined with like the K212b, and is like, isn't it possible that there was a society that existed before the society that we know today?
Absolutely.
Like, isn't it possible that 2 billion years ago a society started?
Yeah, I mean, maybe not on Earth, but you had asked me before, if I thought life existed out there in the universe, and I think yes, likely it does. But will we ever be able to communicate with it? Probably not. And there's two reasons for that. I mean, one is space is huge. So imagine the planet that's orbiting closest to us outside of our solar system, the planet that was discovered around Proxima Centauri. That star is 4 light years away. So if we send a message, let's imagine that life has been confirmed there somehow. We send a message to them, saying hello or whatever. It takes 4 years for the message to get to them. Then they're going to have to, respond in some way.
Mm-hmm.
That's going to take 4 years to get to us. Now it's taken 8 years, and all we've managed to do is greet each other. So that's the closest star to us, but most of the stars are hundreds or even thousands of light years away. So if you try talking to any known civilizations that you might discover there, it's going to take, you know,
So that actually really plays into the theory I came up with, and the theory was that there was, just say for example, say 3 billion years ago, 2 billion years ago, a society existed like ours, and our society is like 4 or 5 thousand years old that we know of. You know, so say 2 billion years ago, a society existed for 20,000 years,
Mhm.
and how much more advanced they would be than we are today. And like, I mean, I feel like a billion years, 2 billion years is enough time that there would be nothing, no trace of anything
Yeah.
besides a Stonehenge,
Right.
maybe. You know,
Well, the universe, it's 13 billion years old.
Right.
There's plenty of time for civilizations to have developed around a star.
even on Earth.
But probably not on Earth. Because, Earth, it was inhospitable for quite a while. It was just too hot for
At what point did
anything.
it become hospitable?
Probably around the same time that Mars was wet, 3 billion years ago. I think is when
So
it
it
started
could have
to cool.
sustained life on Earth 3 billion years ago. So
we
move
know
up,
we know that it did. It
so
it
move
had
up a billion years.
it
So now we're
had
at 2 billion years ago. Say society. Say there was a society formed. Say they are 10,000 more years advanced than we are today. They discover a planet that is habitable, that has people on it. And like you said, you send a message, I don't know, 100, 200, thousands of light years away. They travel at like, these like speed of light, like they break the speed of light with this travel, like this technology that they have to travel there. So now their time has been warped, and they could be there right now today.
Yeah.
From
I suppose this may be possible, but we know that there was life on Earth, 3 billion years ago. But again, it was single-celled organisms. It wasn't,
we know
you know.
that though.
Mhm. Yeah.
So we know there was not people 3 billion years ago.
We know that the life that was there was these, single.
How do we know that?
It's recorded in the rocks, really.
Wow.
Yeah, you can see the biosignatures within the rock layers of the Earth that show us that yes, there was life, but it wasn't necessarily what we would consider intelligent life.
Mhm.
Probably didn't even have the ability to think because it was just a single cell. All it wanted to do was eat and replicate. Make more of itself.
Well, how far could evolution get in a billion years?
Um, Now you're talking biology, which is not
So it's got to be
not
pretty
my
far.
area.
It's got to be. I mean, it's got to be pretty far.
I
A
mean,
billion years.
So within a billion years, I think you started to get to some of the plant and animal life, but dinosaurs, those were only 100 million years ago
Mhm.
or 200
Right.
million years ago, and humans have really only been the last, I think, 20,000 years. So it takes a really, really long time for life to evolve to the level that you're thinking of. But what I was, what I imagine is that with stars other than the sun, because the universe is so old, it's possible that on some other planet, civilization might have been able to develop over that 3 billion year time scale that we're talking for how long it went from Earth being, basically single cells all the way up to, the life we can see today, including people. If that happened on another star early in the universe's history, universe started 13 billion years ago. So, say 10 billion years ago, life started to develop on another star. That star is no longer there anymore. That star would have exploded. So, life that was on that planet probably can't survive that. We can't survive when the sun runs out of fuel and the sun dies. When that happens, the star is going to expand to, the estimate is anywhere between the orbit of Venus and Earth itself. So, we'll either be completely enveloped by the sun, or the sun's going to be stopping a few million miles from us, and we're just going to.
And then we're
K2
12B.
Right. Then we just become K2-12B, exactly. Yeah. And we just vaporize. But that's 4 billion years from now. We don't have to worry about it today.
Really?
But
they know that?
Yeah. We know how fast the sun is converting the hydrogen into helium. It's doing this through nuclear fusion. It takes all of the hydrogen that it has in its core and it's fusing it into helium. We know the mass of the sun.
How does it fuse it into helium?
The temperatures and pressures at the core of the sun are so great that the helium atoms will collide with each other and they'll stick and become a helium atom. And
we can't replicate that on Earth for energy?
No, we can't, because the temperatures, we're talking a couple million degrees.
Wow.
Yeah, it's very hot at the core of the sun. So we know how big the sun is. We know how much hydrogen is there. We know how much helium is there at the core. So we can calculate, how much energy or how much time it has left to convert that hydrogen into helium.
Could you imagine being on Earth like 1,000 years before that happened? You're like, fuck, dude.
I knew I was supposed to figure something out.
Or like 30 years.
Yeah.
And you're like, oh, man, this thing's going to go any second now. That'd be horrible.
Yeah, everybody's like turning in their homework late, trying to.
Would it just be like, whoop?
I think it would be.
Or like a slow roll.
I think it would be kind of slow, but astronomers.
Like, that sun's getting fucking big, dude. It's getting hot.
Astronomers aren't really the right people to ask, about timescales, because we talk about things being soon or slow, but we're talking on astronomical timescales. Yeah. So. A great example that I love is, we talk about the star Betelgeuse, one of the really bright stars that you can see in the nighttime sky. It's the shoulder of Orion the Hunter. That star is going to go supernova soon. And, you ask any astronomer, they'll tell you, yeah, that star is going to go supernova soon. And, when you ask them, like, okay, well, like when? And, it could be tomorrow, but probably going to be about 40,000 years from now. It's really soon. Yeah. So, I say that it's going to expand kind of slowly, but I guess I don't really know what that time scale would look like.
How many light years is that from us?
Betelgeuse?
Ish.
It's either 350 or 630. I'm trying to remember which way those.
So that's how long it takes us to.
Yeah.
So it might have happened already.
Yeah, technically it could have already happened, but
300 years ago.
Yeah, but we won't know until the light from that supernova actually reaches us.
And will we see that happen?
Absolutely. Yeah.
What will that look like?
So when it explodes, the star, it's going to get significantly brighter. In fact, I think estimates suggest that it's going to be bright enough that we would see it in the daytime sky.
Wow.
And so it would suddenly just brighten significantly more than, it is today. And then it will just slowly fade out as the
That's so sad.
As the star dies.
That's really sad.
It is kind of.
Wow. It's crazy. Wow. So all my theory. So I'm just my theories suck. Totally wrong.
Well, I mean, I like I said, I think that life could exist, and I think that it is possible that there were civilizations back in the past, but not really part of our solar system. They would have been around other stars. There's probably some around stars today, and we just we have no way to confirm it. What if they have
James Webb telescopes?
Yeah, they might have something like the James Webb, and
like huge, like way better than James Webb.
Right? Yeah, maybe they'll see us. There's even a whole research division, that's trying to find those signs of alien life. It's the Search for Extraterrestrial Intelligence, SETI, and they're helping, trying to.
Is there anything
to
like
figure out
anything like anything that could hopeful, like anything that they think like are they have any leads on extraterrestrial life?
Not that I'm aware of yet. I think that basically what they're kind of doing right now is they're actually beaming out radio signals that are just constantly going out saying, hi, this is where we're located within the universe, and it's all binary code that we're just sending out as radio signals out into the universe in hopes that maybe somebody would
so
pick it
if
up.
you were on this other planet, like how would you receive that? Like say you were.
That's actually a question that I've always had. I've always wondered that too. Like, sure, it's possible that civilization might also have radio receivers that would
they're
be
all
able
like
to,
in their car and they're like, what the fuck are these people keep trying to get us to go over there for?
Yeah, so we've been sending out all of these radio signals. I mean, even just like, the radio that you turn on in your car, that those radio signals that we're sending out around the Earth, they're actually also propagating out through the solar system and into the universe. So,
do they ever stop?
I mean, I guess if the radio station goes dark, but it's
the sound
it's
wave just continues forever.
That radio signal is just going to be continuing on forever, and so some planet that's in the way of that wave, would get to hear whatever we were playing that particular day.
That's amazing. You can't hear 94.1 WIP from like Atlantic City. But
yeah. Some planet around Betelgeuse, they're going to be able to
like sports radio.
Yeah, they're going to be able to pick it up.
Yeah,
but like I've always wondered that too. Like, what's the likelihood that they're going to have radio receivers to be getting our radio signals, or we send out that information from SETI in particular. It's being sent out as binary code, which I guess those astronomers feel like that's going to be
like a universal language.
Exactly.
Yeah.
But how do we know that?
Yeah,
like,
what is this nonsense?
So, is this supposed alien civilization that has a radio receiver to get our signals, like they're just going to get all of these ones and zeros? Are they even going to be able to translate it? Like, supposedly that translation is also built into the signal that they're sending out, but I don't know. It boggles my mind how they come up with this, but there's smarter people than me that are working on that project, so I'm sure they've thought through some of this stuff and maybe have a better answer than I do. But
for it. They're like, just send it. They'll get it. They'll understand.
Yeah,
They'll figure it out.
Somebody will figure it out, right?
Yeah, they're just like listening to their weekly radio show, and it's like 001000. It's like, this is Earth again. God, these guys are annoying.
Yeah.
Amy, thank you so much. I really appreciate you coming down here. I appreciate the time. I appreciate you answering all my ridiculous theory questions. It's been very enlightening for me. I hope the audience gets a kick out of it. This is great. Thank you so much.
Thank you so much for having me. I've had a lot of fun.
Yeah, great. Okay, we'll talk soon.
All right, great.
All right, see you.
Thank you.
Bye.